Hello there. The summer's almost here. If you have ever wondered how an AC cools your home, you're at the right place. If I were to tell you that the evaporator, the place where something boils, cools your room, and the condenser, the place where something condenses, heats up the world, would you believe me? How counterintuitive. We generally relate boiling with heating and condensation with cooling. That is only true if the pressure were kept constant. That understanding goes out of the window once we include the ability to change pressure into the mix. Let's look at some of the laws that will help us understand the functioning of an AC. Number one, gases heat upon compression. Gases cool down upon expansion. A liquid has to gain heat energy to be converted into a gas. We call it as the latent heat of vaporization. It is usually a very high quantity. A gas has to lose heat energy to be converted into a liquid. We again call it latent heat of vaporization, but the process is reversed. The material loses energy instead of gaining. Number five, the boiling point. The temperature at which a liquid converts into a gas increases with increasing pressure. The boiling point lowers at lower pressure. All of these six principles come together in a symphony to make an AC work. An AC is a closed heat transfer system, primarily comprised of these five parts. Number one, refrigerant, sometimes referred to as an AC gas. It is what moves within an AC and transfers heat from one part of the AC to another. It needs to have specific properties which are beyond the scope of this video. Maybe in a future video I'll cover those. Number two, condenser, the place where refrigerant cools down or condenses from a gas into a liquid, thereby releasing a lot of energy, which we just discussed, the latent heat of vaporization. It makes the condenser and as a result the outside surroundings hot. Number three, the expansion valve, a valve that allows the refrigerant in liquid form to flow from the high pressure condenser into the low pressure region, which is called as evaporator. Number four, evaporator, place where the liquid refrigerant evaporates into a gas, thereby taking up a lot of energy from the surroundings. The refrigerant boils, but it cools the evaporator. Number five, the compressor. It compresses the low pressure gaseous refrigerant coming out of the evaporator, thereby increasing its temperature. It's a closed system. It's a cycle, so we could start from anywhere, but let's start from the compressor. It takes the gaseous refrigerant which is at low pressure from the evaporator and increases its pressure. When the pressure increases, the temperature of the gas increases. This high temperature gas goes into the condenser. It interacts with the walls of the condenser, and inside the condenser we have a high temperature gas, and outside it we have air at atmospheric pressure. So heat transfer happens between the gas inside the condenser and the ambient. The gas inside the condenser loses its heat to the ambient, and in the process it cools down. And it cools down so much that it condenses into a liquid, hence the name condenser. Remember that the refrigerant in the condenser is at high pressure. So the boiling point of the refrigerant is high. At that given pressure, it is higher than the ambient temperature. So interacting with the ambient, it cools down so much that it condenses from gas into a liquid. During condensation, a lot of energy is lost to the ambient due to the latent heat of vaporization. So now we have a liquid refrigerant at the end of the condenser coil close to the expansion valve, which is much cooler than the gaseous refrigerant that entered from the other side, that is the compressor. The expansion valve is very small in diameter, so it doesn't allow a lot of refrigerant to go from your condenser into the evaporator. When the refrigerant enters the evaporator, which is at much lower pressure, its boiling point goes down. So it evaporates from a liquid into a gas. In the process, transferring heat from the ambient outside the evaporator coil into the refrigerant. Remember, the latent heat of vaporization is required to convert a liquid into a gas. Where does that energy come from? It comes from the air outside the evaporator. Once the air loses heat energy to the refrigerant, it cools down. So the refrigerant goes through one gas liquid transformation and one liquid gas transformation in one cycle of refrigeration. It loses energy during the gas liquid transformation, thereby heating the ambient which is outside the home, and it gains energy during the liquid gas transformation, thereby cooling the ambient inside the home. There are fans on both the condenser and evaporator to speed up the heat transfer using convection. Otherwise, you would be limited by radiation. When the refrigerant condenses or cools down, it heats up the world. And when the refrigerant evaporates or boils, it cools down the room. Still counterintuitive?